All right, I sure hope this is working. Good morning, guys. Good morning. I'm sure you're thrilled to be here this early in the morning. I had some things come up, and I was not able to make it today. You might have thought you weren't doing anything, because I won't hear, but you were wrong. We are absolutely doing something today, though it's not too crazy. Same kind of concepts we've been doing. We're going to continue with lateral area, surface area, and volume, just moving through the shapes here. I know you've seen problems like this before. I want to make sure we cover them though, because the SAT loves these kind of problems. They love to make them look super scary when they're actually not too bad. So I want to make sure y'all can work through all those lovely, lovely formulas. In particular, today we're going to look at cylinders. So we're going to do surface area and volume of cylinders. Okay? And before I just start throwing out formulas left and right, let's remind ourselves of some definitions here. First of all, if we're going to be looking at cylinders, I think we need to draw a cylinder. Okay, so let's label the parts of this here. Remember, for a 3D shape, the base is the part that is parallel. It's the part of the shape that's parallel. For this shape, it is the circles. Those two circles there, if you imagine them getting bigger and bigger and bigger and bigger forever, those two circles would never cross, which makes that my base. So I will label that in here. The circle itself is the base. The vertical segment here is the height. And if I put the center of the circle here and draw a line there, that is my radius. And just like with right prisms, we had a oblique prism. The same is true of cylinders. You could have an oblique cylinder. Again, I'm not going to write down the definition. It's not that important. It's just kind of a special case that I want you to have at least seen, just in case it pops up somewhere. And remember, all the word oblique means is slanted. So an oblique cylinder is just a cylinder that is slanted, something like this. Your book has a much better drawing of one, if you would like to see that. Yeah, something like that. So yeah, let me give it a name. This is our oblique cylinder. And for this shape, what we use for the height, because remember, it's got to be a vertical segment. It can't be this slanted bit. I have to use the given measure here. This dotted line that comes down and connects with the base like that. The length of this vertical dotted line is what I would use for my height. Okay. I gotta remind you of one other definition here. I want to remind you what lateral area is. I'm not going to redo surface area and volume. Those do generally stay the same. The lateral area is the same as well, but there's something I want to emphasize here with the cylinder. Okay, so remember, lateral area is just the total area of all of the surfaces, not including the bases. Okay, so for this, I'm excluding my circles on the top and bottom. So for this, the lateral area of a cylinder is going to be the area of the curved surface of the cylinder. Yep, so we are excluding the top and the bottom. We are just looking at the curved sides of this thing. All right, and of course we've got a formula here. LA for lateral area is going to equal 2 pi RH. Okay, not too scary there, And of course we're familiar with all these. We've got constant pi, R for radius, H for height. Okay, there is something I'd like to point out here, and if I'm pointing it out this way, it might come in handy on the classwork, hint, hint. So if I look at this right here for a moment, you might realize that formula might seem kind of familiar. And that's because it is. that is the formula for the circumference. And I hate to change colors in the middle, but this one sucks. Let's go with green. This part in orange is in fact the formula for the circumference of a circle. 2 pi r h. One of the questions on your classwork may be related to that relationship. So yes, definitely note that that formula appears inside of that one. Okay. Let's do an example. Example 1. Right, we're going to find the lateral area in terms of pi. Right, definitely don't forget that in terms of pi component. All that means is I leave pi in my answer. I do not round it. Right, and of course I need to actually draw the shape for us here. Let me not trip over my new box. Okay. Then we got something like this going on. All right, we got a height of 9 feet, and we got a radius of 4 feet. All right, lovely. And again, anytime you're working with a new formula, write that formula down. It helps so much with remembering it, working with it, feeling comfortable with it. So that's what we're going to do. Let's see, my formula here, LA equals 2 pi RH. Excellent. All I have to do from here is plug and chug. A lot of the time, these aren't too bad. Let's see here, 2 pi, the radius is 4, and the height is 9. Okay, I want my answer in terms of pi, so I don't have to worry about that too much. I just need to multiply all my numbers here. 2 times 4 is 8, 8 times 9 is 72. So my answer is 72, let's see, we're doing lateral area, so this would be feet squared. So just starting out, we're going to see what all these formulas look like just using them in simple cases, and then we'll look at some more challenging type of problems. And those are the ones I'm really looking forward to. And if at any point I start erasing or I start going too fast, it's a video. By all means, pause it. I have no issue with that. Not that I would be able to tell otherwise, I suppose. But with that being said, let's look at the surface area of a cylinder. Okay, here. And again, I'm not going to redefine surface area. I think that one's pretty straightforward. That is just the total area of all the surfaces. This time I include the bases. Okay, so my surface area of a cylinder is going to be equal to the following. We've got 2 pi r squared plus 2 pi r h. So the two components do look very similar. I think that's helpful though. It makes it a lot easier to remember what it looks like. And, oh, I forgot to set this equal to something. We can say this is equal to S for surface area. That's fine. And I do want to show you this other form of this equation. Some people think it's easier to remember, some don't. I'm not forcing you to know both. You can choose. Choose whichever one is easier for you to remember. So you can also write this formula like this. Let me see here. I'm remembering how it goes on the spot. Okay, so I can write it like this. So yes, if this is easier for you to remember, use this version. You never have to worry about that version in your life. Okay, and while I'm at it, let's go ahead and get the volume on here as well. All right, that formula is going to be, I will not forget my letters this time, V equals pi r squared h. Okay, now I'm going to point out something kind of neat here. This time it doesn't directly help with the problem under your classwork, but this would be a really great test question. So right here, Well, that sure looks familiar. And in fact, it better be, because that is the formula for the area of a circle. Area of a circle. And again, I'm not doing a problem with that or anything. I'm just pointing that out. I'm saying that's worth noting. Remember that. Okay, now let's actually look at some problems. See, what are we going to find first? I think we'll do surface area first. Okay. Let's see here. Let's see. Number 2. Find the total surface area in terms of pi. Okay, let's draw that cylinder here. All right, what do we got for this one? We got a radius of 10 centimeters and a height of 18 centimeters. And again, this one's just kind of plug and chug. Make sure you know how the formula works. All right, let's see here. S equals 2 pi r squared plus 2 pi rh. Well, let's see. I definitely know the radius. That is 10. So we got to square that. Multiply by 10 here, and of course the height is 18. Okay, so if we simplify this a little bit, first I'm just going to square the 10, and over here, actually I'm going to do a little more than that one step. We're smart, we can do this. 10 squared is 100, 100 times 2 is 200. So here's 200 pi. And over here, 10 times 18 is 180, times 2 is 360. So plus 360 pi. Okay, beautiful. If I add those together, that is going to give me 560 pi. Centimeters squared. Almost forgot. Yeah, so not too bad. Volume will work out very similarly. Very similarly. Actually, I think I can fit that right here. Find the volume in terms of pi for the following cylinder. Okay, we got 20 meters here. I wrote that really small, I just realized, my bad. That is the number 20, and that is an M next to it for meters. Okay, and I got 42 meters here. Oh, awesome. Even better, guys. I misread my own handwriting. Right up here, this should be a 30. That's my bad. 30 meters. Okay, so let's get that formula up on the board. See, V equals pi r squared h. Well, just like before, I know all the necessary information, so I just plug in. The radius is 30, so I gotta square that. I gotta multiply by 42. Okay, I reckon this is gonna give me, and I'll let y'all put this in your calculator to check, 37,800 pi. And note here, I'm calculating volume. I'm in the third dimension, so meters cubed. Lovely. Okay, so all these aren't too bad. This is just, oh goodness, can you plug the right number into the right place and hit all the right buttons on the calculator? That's nothing too crazy. My real favorite kind of stuff with this is the next couple problems. The ones that really make you think a little bit. The ones that make you feel like you're solving a puzzle. Those I properly enjoy. All right, so we'll look at those very soon. I'm gonna cut this clip short here, and I'll be back very shortly. All right, y'all, I've returned with the goods. I've got them on the board. All right, and I'm looking here. I think this should be okay to read. It's hard for me to tell. I'll read them out loud just in case. Okay, let's start with number 4 here. All right. If the lateral area of a cylinder is 878 meters squared, and the radius is 26 meters. Find the height. Oh yes, these are my favorite kinds of problems. These are like putting a good old puzzle together. All right, excellent pro tip for questions like these. You can kind of categorize these questions as find the missing dimension questions. So they give you everything you need for a formula except one part of it, and you got to find that missing part. You generally start these all the same. You want to first figure out what property they calculated. Now what I mean by that is, did they calculate circumference? Did they calculate area? Did they calculate surface area, lateral area, volume? What was computed? That's what I need to find out. And thankfully this one tells me pretty quickly. They tell me the lateral area was calculated. So what that means for me is if the lateral area ended up being calculated, well then I'm probably going to need the lateral area formula. And that formula is the following. Okay, 2 pi r h. Lovely. Okay, here. Now that I have a formula to work with, I've got some foundation to build on. From here, I'm just going back through the problem, and I'm figuring out what each number should be plugged in. Okay. They tell me the actual lateral area is 878. So this L right here can be replaced with 878. This will all be equal to, let's see here, 2 pi. They told me the radius is 26. And they did not tell me the height. That is what I'm looking for. I gotta find the height, so this will remain h. Okay. So this is actually, this isn't too bad. I've had y'all do stuff like this before, especially with the arc length and area of a sector stuff. All we got to do here is distribute this. I got to multiply. Oh goodness, I lost my spot on the page. There we go. That's going to be 52 pi h, all equal to 878. And to get the h by itself, no trouble. Over here I have a product of terms. So I do the opposite and divide out the ones I don't want anymore. Yep, so divide both sides by 52 pi. Now what that is going to tell me is that, oh goodness, h is equal to, and, okay, I'll write down the unreduced version first, then I'll reduce it. Okay, so we got, 878 over 52 pi. Excellent. Right, now let me grab my calculator. I did not specify on this one whether or not to do in terms of pi or as a decimal. For these three, I'm going to do both. I want you to see what they both look like. Okay, so if I divide 878 by 52 in my calculator, that fraction reduces to 439 over 26, and then the pi just hangs out down there. Okay, great. I would like a decimal approximation just to get a feel for it. And remember, when you type this in the calculator, make sure you put parentheses around that, or it is going to give you the wrong answer. No if, and, or buts about it. Remember those parentheses. If you do that, let's see here, and do this yourself, make sure you're doing it right. Oh, you're going to get 5.37. What unit are we using? Meters. And that'll do it. All right, I'm gonna give y'all a minute to write that down, and then we'll look at number 5 here. Okay guys, chapel is almost over, and I need to deliver the phones. Let's see if I can get these two done in 15 minutes. Okay, number 5. If the base of the cylinder has a circumference of 93 meters, and the height is 17 meters, find the volume. Okay, definitely pause on these two if you need to. I'm gonna go a little quick because I'm kind of in a rush. So, just like before, I wanna figure out what formulas I need. It looks like I'm gonna need the circumference formula and the volume of a cylinder formula. So first things first, let's write those bad boys down. Circumference of a circle is 2 pi r. And let's see here, the volume of the cylinder formula is pi r squared h. Lovely. So this one has two formulas going on. What'll end up happening with this one, since I know the circumference, I'll end up plugging that in here, and then that will let me solve for the radius. Then in combination with that radius, that height right there, I can plug in everything to the volume formula. So that's my attack strategy. That's my game plan. Let's do it. All right, the circumference is 93. That's going to equal 2 pi times the radius. Don't know what it is. I got to find it. Okay, I'm going to divide both sides by 2 pi. And again, when you put this in the calculator for a decimal, do not forget the parentheses around 2 pi. And if you do that, you're going to get about, oh goodness me, 14.8. And when you're working on the classwork, guys, I do not mind. Like if you have something really bad right here, I don't mind if you round at this point. The calculation I'm going to do from here, let me see, what would it make more sense to do? Yeah, I'm going to calculate it exactly using this. I'm not going to round it, but I don't have an issue if you choose to round the radius here. Okay, so now I just need to take my radius and my height and plug it into the volume formula. Okay, so that's going to give me pi times 93 over 2 pi squared times 17. And now you know you might be freaking out. I promise it's not that bad. Like, it looks rough, and your answer, like, it's not a pretty answer, but like, it's not too bad to get there. It's not too bad to get there. First things first, I got to square this fraction. In order to do that, square the top and square the bottom. Okay? So 93 to the second power. If you do that, you're going to get, let's see here, I know I wrote it down, 8,649. Okay? Now, if you square the denominator, if you square 2 pi, 2 squared is 4, and pi squared is pi squared. Not too bad there, not too bad. All right, what I'm going to do here now is multiply the 17 times this 8,649. If I do that, I am going to get, see, I don't want to do too much at once here. I'll have pi times 147,033 all over 4 pi squared. All right, then just one more thing to do. Here I've got a pi. That can cancel with one of the pi's I have down here. So my final answer in terms of pi would be 147,033 all over 4 pi. And again, this pi cancels with one of the pi's right here. If you put this in your calculator, which I did remember to do this time, that is 11,700.5 meters. Completely forgot that unit. Okay, so I'll wait a couple seconds, then let's attack number 6. 6 is a little easier, number 5. Okay. If the volume of the cylinder is 225 cubic centimeters and the height is 12 centimeters, find the diameter. Okay. This is another thing these problems will try and do. If you look back at your notes, the diameter is not in any of the formulas. It's the radius that's in the formulas. What that means then, to get the diameter, I need to get the radius first, then double it. That's going to do it for me. That's going to be my line of attack here. Okay, let's see what formulas they gave me. They told me the volume of the cylinder. Okay, so I can write that formula down. All right, and let's see what I can substitute in here. I know the volume, that's 225. Pi is just pi. Let's see, the radius I don't know, so we'll leave that as radius squared. And the height is 12. Okay? pi times 12 is just 12 pi. So I'm going to divide both sides by 12 pi to get rid of that. Okay, so I got 225 over 12 pi, and that's going to be equal to the radius squared. Okay, so I'm definitely not done here. And Lana, I've seen you make this mistake way too many times. Please don't do it again. Yeah, you gotta actually square root this here. You're not done at this point. You have to get rid of that exponent of 2 by taking a square root of both sides. So my radius is in fact equal to the square root of 225 over 12 pi. Lovely. Lovely. Now I can definitely simplify that down a little more. I think for the purposes of 10th grade geometry, this is okay. I think this is okay. For my algebra 2 kids, for Savannah and Hannah, you could apply the square root to the top and bottom and make this 15 over the square root of 12 pi and rationalize it and all that fun stuff. But I think we'll leave this here. I think this is a good form. But remember, I'm not done. I need that diameter. So all I gotta do is just make sure I write the diameter is gonna be twice the radius. So 2 times the square root of 225 over 12 pi. What unit is this? Centimeters. And if you were to calculate a decimal for that, let's see here, what is that going to be? This might take a minute of button mashing here. So we're going to divide under the radical, then we're going to square root, and then we multiply by 2. And that will give us 4.89 centimeters. Okay. Not too bad there. Not too bad. Oh, I forgot the box. Okay, so that is all the problems I have for y'all today. I do have classwork planned. Real quick, I think I forgot to mention this at the beginning of the video. The homework that was initially due today and test corrections, definitely the homework, if you have test corrections to give me, keep all of that. Keep all of that. I will be back tomorrow. Please just keep it till tomorrow and give it to me then. I don't want to get all crazy with this. Okay, now the classwork for today, it's all on this content. There are 6 total questions, one of which is a challenge. I do want you to try all of them, including the challenge. Now, because it's a challenge question, I'm going to be very forgiving in the way I grade it. Please don't stress about that. But the other 5, I think, definitely should be completely doable with these given examples. So yes, work on that classwork. If you finish, then you must complete your homework first before you do anything else. You've got to do this first. Page 414, A through D. Do that before you're allowed to do anything else. If you do finish that, if you're completely done with the classwork, you're completely done with the homework, then you are allowed to work on other school assignments. Okay. I don't think I forgot anything. Y'all have a good rest of your day. Make me proud. Be nice to Ms. Myers. And I'll see y'all tomorrow.